In this presentation, we'll be looking at Simcenter FloEFD for NX, which is a general-purpose 3D CFD tool from Siemens Digital Industry Software. This presentation is a first-look demonstration where we'll cover the most common usage scenarios for FloEFD, and we'll see what the workflow looks like from start to finish. So first of all, what is FloEFD? FloEFD is a front-loading, multi-CAD embedded CFD tool for designers. Front-loading is the concept of performing your simulations earlier in the design cycle to maximize the impact and catch issues before the late-stage validation phase. There are several features to differentiate FloEFD from other tools on the market, and this slide aims to highlight some of the key features and functionalities. FloEFD is a general-purpose tool which can be used in a wide range of flow and heat transfer problems. It has been specifically developed for non-CFD specialists to use to get fast, accurate results. The Mesher and Solver have unique proprietary technologies which facilitate the streamlined CAD-embedded analysis approach of this product. The result is a drastic reduction in barrier to entry and overall CFD simulation time. The tool is available in 5 versions to support your MCAD workflow. We'll be looking at the NX version in this demo, but the process is identical for other MCAD systems. Here is the roadmap for our demonstration today. This workflow mirrors the actual steps taken to go from geometry to CFD results using the software. We'll be looking at each of the steps in a little more detail to highlight some of the unique features of FloEFD for NX. The model we'll be using is an IGBT liquid-cooled module, which can typically be found in an electric vehicle or renewable energy application. The modules are used when large amounts of current need to be switched on-off rapidly to control a motor, for example. The power semiconductors can generate kilowatts of heat under sustained load, so liquid cooling is the only way to keep them operational and reliable. A typical result visualization can be seen here with the temperature variation on a surface plotted along with the water flow streamlines. The first step to be covered is the NX integration. FloEFD is natively embedded inside Siemens NX. We support the latest versions of NX all the way back to NX7. This means there is no need to transfer geometry from CAD to a CFD tool. All of the assembly and part parametric definitions are maintained so modifications can be made easily. This is especially powerful when it comes to optimizing the geometry. Compare this with using neutral file formats like STEP, where all parameters are stripped out and you're left with a dumb solid. The fluid region is automatically detected based on the internal flow volume, and this is updated when geometrical changes occur. The image shows the water region detected by FloEFD. Let's look at some of these features in FloEFD. Here is the NX interface in modeling mode currently. If we explode the assembly, we can see the parts which make up the IGBT cooler. It's important to model all the materials in the thermal path from the semiconductor to the fluid. We can see the silicon, the solder, the copper chip carrier, and the thermal paste attaching the chip carrier to the base plate. The casing is made of aluminum, and the whole assembly is designed to operate in vehicle underhood conditions. There is the addition of lids, which serve the purpose of closing the water region and for applying flow boundary conditions. Let's look at the copper baseplate in more detail. If we open the part, we can see it's been designed very simply in NX using an educated guess for its predicted performance. Looking at the NX expressions, we can see there are 3 parameters controlling the heatsink pin width, draft, and pattern spacing. The model has been designed this way with later optimization in mind. Jumping back to the main assembly and taking a cross-section, we can see there is some geometrical overlaps between the parts around the O-ring and silicone potting compound. FloEFD has no issue with overlapping and dirty geometry. There is no need to spend time fixing this, just be careful with material priorities. FloEFD is started from the menu tree under Simulation. This starts FloEFD mode and checks out the license. We can see the addition of the Flow Analysis ribbon toolbar, which is used to control the analysis. The lids on the inlet and outlet can be created automatically using the Create Lids tool. Finally, let's use the FloEFD Check Geometry functionality to check the fluid region. Clicking on the Show Fluid Volume button will highlight on the screen where the fluid regions are. There are some small enclosed volumes around the O-ring which can be ignored later, but the main flow region has been detected correctly. This fluid volume part doesn't need to be created in NX. It is automatically created and updated. The geometry is now ready for FloEFD analysis. The benefits of having an NX embedded approach are that there is none or minimal geometry simplification necessary. Geometry changes are detected and the project is updated automatically. The tool is easy to use for existing NX users as it's just an extension of the CAD tool. What we just saw was the NX embedded nature of the software and how designers can leverage pre-existing NX models to perform a CFD analysis. The familiarity of the NX interface and FloEFD being a logical extension makes the tool easy to use for the NX designer.